All right. Welcome, everyone. AWS on air. I see some people in the chat that are starting to say hello. Keep it coming. If you've got questions, we're going to be able to, bring them up and ask your questions here. We'll answer them. So we've got EFS is what we're talking about. But first, let's do some intros of who's here. My name is Jillian, and I'm a startup solutions architect. I've got a fantastic co-host, Kyle. Say hi.
Hey there. Hey, I hope you could hear me. I'm here in the Venetian at reInvent 2022.
Oh, your mic, I don't know. It's a little bit hard to hear you. I know. And Anant, is that the case too? Were you able to hear Kyle?
How about now?
It's good enough for me.
Oh, maybe it's just me. Oh, I think it was just me. Sorry.
We'll
The
try
volume
this.
down really
Check,
too low.
check
My bad.
1, 2. All right. All righty. Hey, yeah. So I'm Kyle Dickinson. I'm a senior threat detection and incident response solution architect. I'm actually here at the Venetian right now at reInvent 2022. So sorry for the background noise, but we'll make do where we're going to be talking about some awesome stuff today.
Yep. All right. And my name is Anant Vaidyanathan. I'm a principal product manager on the Amazon EFS team. I'm taking this on-air session back from my hotel rooms just so that I can get some quiet spot. So, yeah.
Great call. And so for those who are not familiar with EFS, can you just give an overview of what is Amazon EFS?
Sure. So Amazon EFS essentially is a file storage solution that's designed from the ground up in that it's cloud native to leverage the cloud, right? It's serverless, it's fully elastic, and it delivers a simple experience for builders, data scientists, researchers, DevOps professionals, essentially folks who are building and deploying cloud native applications and workflows on AWS. And so I think of EFS as providing storage that kind of just works for builders, right? Without them having to worry about resource sizing and capacity planning, or whether does it work from EC2, does it work from containers or Lambda functions or any of that, right? It abstracts away all of those complexities, and it's essentially the easiest or the simplest way on AWS to share data across share data for cloud native applications and workloads. So happy to talk about some common use cases as well if you want me to do if you want me to do that.
Yeah, and I have actually seen quite a bit of buzz about this feature release on the social media sphere. What is the problem that this is going to be solving for our builders and developers to help increase the performance and functionality of their workloads?
Yeah. So EFS, as I said, it's primarily meant for builders and data scientists and DevOps professionals. And many of these folks, as you're building cloud native applications at cloud scale, you're now operating on large and fast growing volumes of data, right? Your data sets are large and they keep growing, and so you want your file storage solution to automatically scale to meet the performance needs of these applications. Think of applications such as machine learning inference, right? You're doing some sort of training, and then you're doing ML inference for things like financial modeling, computer vision sort of applications, or NLP sort of things, or content management systems. Like you just have a website and you don't know, when user traffic might just spike up because you had a blog post that went viral, or you have a retail website where you just put on a promotion over the weekend and you have a huge unpredictable surge of traffic, right? And so typically when you think about a file storage solution, you want your file storage solution to scale to meet the needs of these spiky or unpredictable sort of traffic, right? So previously what would happen is these sort of performance planning is really hard to do, because you really can't estimate what your performance requirements are, right? You really don't know what they are. And so typically what you might end up doing is you either set your performance thresholds for a file system too high because you just want to be safe, so that so that you meet your application SLAs and your end users don't get a bad experience or a slow experience. And so what ends up happening then is you end up overpaying for your underutilized resources for the time when you aren't using that much, right? Or what you might end up doing is you might under provision because you don't know, and what ends up happening is your users get throttled and your application gets throttled and your users have a bad experience, right? Either way, right, whether you over provision or under provision, that's something you just don't want to do, right? You don't want to actively do that, because as a builder, you want to focus on your application. You want to focus on the business value that application provides. You don't want to focus on storage. Okay, does my storage scale? Do I have to keep monitoring all of that? You just want a storage solution that just works and can meet the performance requirements that your application needs. And so that's what we kept hearing from customers. And so that's why I'm super excited about elastic throughput and all the buzz that is generating on social media, because what that essentially means is, for builders building, let's say, containerized workloads or serverless workloads, you now have an application stack, whether it's on the compute side or the storage or on the storage side, that just scales automatically, elastically, and from the storage side specifically for storage and performance, right? It just scales up when your application needs it, when your application demands it, and then scales down when your application scales down in terms of traffic, and you only pay for what you use. You don't overpay for the time that you aren't using. So which is why it's like super exciting, especially for workloads, like I said, machine learning inference, CI/CD tools, analytics, SaaS applications where you're building applications for a large number of users and you can't predict application traffic and so on. So a huge number of use cases that really are enabled with this elastic throughput feature.
This is awesome. I mean, I know I work with startups, so I can know that a lot of startups, when they're just getting started, they have no idea what their traffic levels are going to be. So this is perfect for that use case. And I'm sure there's a lot of people who maybe have used or using EFS. And so they're like, all right, we've got provision throughput, we've got elastic throughput, we've got bursting throughput.
Yep.
Help me decide what should I use and when.
Yeah. So if you step back a little bit and think about, the throughput capacity, or the throughput of a file system is essentially the speed at which your file system can serve data to the end application, right? And EFS provides, as you said, already provides bursting and provision throughput. And now with the introduction of Elastic, it provides a whole range of throughput options. So I would say that the way to think about this is bursting throughput is great if you want throughput that scales with the amount of storage in your file system. So with bursting, you get a certain set of throughput that scales based on the amount of storage that you have. So as you add more storage, you get like more amount of a higher amount of throughput. So it's great. So you should use bursting throughput if that's the case. But if your application is throughput constrained, right? For example, if you're hitting the limits of what your bursting throughput can provide, let's say 80% of the throughput, and this is something you can look up on CloudWatch, right? Then you should. So this means that your application essentially needs throughput that's independent of storage, right? And you're seeing unpredictable traffic, and you're hitting the limits of the bursting throughput that you get. Then you should consider provisioned or elastic throughput. So let's come to Elastic, right, which is the focus of this one. And Elastic throughput essentially provides as much throughput as your application needs whenever it needs it, and you only pay for what you use. And it's great if like I said, you don't know what your application performance requirements are, or if you have like very spiky or unpredictable traffic, right? Think about the normal state being low steady state, and then you might get like a big spike that you don't know about, right? And that you can't predict. So elastic throughput is great for that. And also if you want to just pay for what you use, right? You don't just for the amount of data that's read or written. So that's elastic. And then finally we have provision throughput. That's already been there since for a few years. And provision throughput is great if you know what your workloads performance requirements are, if you know what the throughput requirements are. And typically if your average to peak ratios are, I would say, greater than 5%. What that means is on average you use throughput that's fairly close to what your peak requirements are, which essentially means you know what your application's performance requirements are. And another reason why provision throughput might be okay is if you need a predictable billing experience, for example, right? And so I would say these are the three ways, maybe some of the decision criteria you could use for when to decide. So just to summarize, it depends on the nature of your application. Does it have spiky or unpredictable traffic? Is it throughput constrained? The second is, can you reasonably estimate or understand what your throughput requirements are? And the third is, like, do do you just want to pay for what you use, or do you want a predictable kind of billing experience?
Best practices that our builders can get started with using this service in a way that will set them up for success for long term?
So I would say, if you're thinking about it for a new workload, right? So let's say a builder's coming in, they're building, let's say, a new serverless workload, and they want to make sure that they're kind of set up for success as their application grows in the future. I would say start off with elastic throughput, because it lets you understand what your application's performance profile is, right? And you can use a CloudWatch to really understand what the nature of your performance metric is. How much throughput am I driving on average? What's my peak? What's my average, right? So let's say that you run it maybe for a week or a month, depending on the workload. You get a reasonably good sense of what your application performance profile is. Once you have that, then then you can choose to continue using ET, because you're like, hey, this is still spiky or unpredictable. Let me just stick with what it is. ET just gives me what I need, and so this is great. Or let's say that it's steady. You understand what the range is. Then, in which case you might choose to switch to provision throughput, for example. So, in essence, I would recommend for a new workload, start with elastic throughput. Just so that you get a sense, and then eventually, based on your understanding of the application performance profile, you could continue to use elastic throughput or switch to either bursting or provision.
I love the way that you just explained that. And for those of you who are watching, I know this is something that I know I'm going to be want to watch again on YouTube, especially the soundbite of what you were just saying about the different use cases and the differences between elastic throughput and provision. So definitely check it out on YouTube afterwards, the recording. And I guess one other, question I had, you were talking about really the best practices. And I'm curious, because you were also talking about the use cases earlier.
Yep.
You see any differences? Let's say you talked about a machine learning workload earlier and a content management system. Do you see any differences in the best practices and maybe which choice they should be able to pick?
I would say for things like typically what we see customers doing is, especially machine learning inference workloads, typically are super spiky, right? Because you run your machine learning inference or your ML training only for a certain period of time, and for the rest of the time, it's either dormant or you have very low baseline activity. So in that case, it is a great fit because let's say your average compared to your peak is super low, right? You're using it, maybe for a few hours each week or a few hours each, or maybe a couple of days each month, in aggregate. And so elastic throughput is a great fit, right? If you have, for example, a content management system, or you're running a website serving web content, again, ET is a great fit because you might have, based on your business requirements, you might be running a promotion, or you might have, and so which may result in unpredictable traffic, right? So in that case, again, you might want to choose ET. But there might be some use cases where, for example, you just have a large amount of storage, and that entitles you to a large amount of bursting throughput, right? Because you just have a large amount of storage. And so in that case, and in that scenario, bursting throughput might just give you the amount of throughput that you need.
That is awesome. Yeah. So for those that want to get started using this, where can they start? Are there any references or articles that they could read, or docs? Always gotta love the documentation, right?
Yep.
Where can customers get started with this new feature that you have?
So I think the best way to get started is by really using the feature itself. And I'm happy to show how easy it is, in fact, to get started, how EFS is really super simple to use and to get started. But outside of that, I'm happy to post in links to our technical documentation or the great blog that was published yesterday as well on elastic throughput. So I would recommend those as immediate next steps if you kind of want to read about it. But obviously, as builders, the best way to obviously get started is always to actually try it out.
Thank you so much for that.
So do you kind of want me to? I'm happy to share my screen and show you how easy or simple it is, if that works.
we're actually coming up on our time. I know it's a party and we can't contain it. However, we will supply the documentation to our viewers so they can understand how to get started, because it sounds like it's pretty simple to get started.
Yep.
So hopefully, they're going to be able to turn it on fairly easily. But
Yep.
It sounds like everyone knows or will know where to get to the documentation and the blog post. And it sounds like some folks will be dropping those links into our chat here. So we'll make sure to get those to you so you can get started using this feature ASAP. It also stands for as soon as possible.
Yep, that's right. That's right. And just to summarize, creating an EFS file system is super simple. When you log into the EFS console, you say create a file system, and you have literally a box, and where you provide a name, and even that's optional, and you can create a file system. To choose Elastic, you just choose your throughput mode as Elastic, and you're like literally good to go, right? Fully Elastic, serverless, and you're ready to use in your application. So it's like super simple.
Anything that's super simple, I'm all in. So I love it. I'm really excited. I'm sure a lot of people definitely are wanting to try it. Anand, thank you so much for being here today, sharing us so much wisdom. Kyle, you are always awesome. And thank you for tuning in to AWS On Air. Stick around. We've got more coming up.
Yep. Thanks, Julian. Thanks, Kyle. See you.